Okay, and welcome to example 4. In this example, we're going to take a look at something very essential to destruction, and that is how to fracture objects and how to use the Voronoi fracture node. So basically, we're going to do some fracturing of this box right here. So how this is going to work is it going to look like this. Let's visualize the pieces. They're going to look like this. Alright, so how do we do this? Well, first of all, we need some points for these cells or these Voronoi fractures. And we're going to use this box as a initial geometry. Then we're going to do a volume out of it, like this, with the iso offset, just to get a volume in it. In the volume, then we're going to scatter some points. Scatter roughly 100 points. Or, well, roughly 100 points. More like 100 points. Because that means that we are going to get 100 pieces. Alright, and then let's feed that into the second input of the Voronoi fracture, and in the first input we input the original box. This is gonna do this. So that means that every single center of these pieces has this point in it. So every point makes a piece, and every point becomes the center of this piece. We can look at this in real time if we slide this. I can slide up and down, and I can increase the piece count. We're gonna keep it at 100 though, for now. We can do an exploded view node afterwards here, and we can see how it looks like. So it looks like this. So this is all our pieces. We can visualize them by clicking here. We get some different colors in each piece. But that's actually all I'm gonna go over for this Voronoi fracture node for now. This is just the basics of it. So next example, we're gonna go over the more into the details of this and how to use the cut, cluster, and stuff like this. Anyhow, so this is how you get the pieces. Another very important part about this is that each of these pieces are now its own geometry, right? But it's still like points and primitives and blah blah blah. We actually want to bring in these pieces as each piece. We want to pack it, and we want to bring it in as a packed object. That will make for a really fast simulation. So we don't have to simulate all of these primitives, all these points. We simply have to simulate 100 points. And how we do this is with a packed node. First of all, we're going to move it up a little bit. Let's see. So with a packed node, as we remember, we can pack this. But if we simply pack it like this, without doing anything in the packed sub, we only got 1 point, 1 primitive, 1 vertices, and 1 packed geometry. What we want 100 packed objects, 100 points, and 100 primitives. So how we do this is we use a name attributes. And this Voronoi node up here is so convenient that it actually gives us a name for each piece. It gives us a string attribute, it's called name. And each name attribute is piece 0, piece 1, piece blah blah blah, up to piece 99, since we have piece 0 and we have 100 pieces. Let's see how that looks in the geometry spreadsheet. So in here, we can go to the primitive attributes, and we can see that there's a multiple primitives. There's 1353 primitives, but some primitives have the same piece attribute here. So the name attribute is a string, right? And the name of attribute on the primitives 0 to 15, the name attribute string is piece 0. That means that all the primitives that are from 0 to 15 are in the same piece. They are simply making up for piece 0. Same goes for piece 16 to 25. They all have the same attribute, piece 1, which means that primitive 16 to 25 is in the same piece. This means that we can, in the pack node here, use the name attribute to pack these primitives. This means that if any primitives have the same name attribute, which means piece 0, piece 1, piece blah 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 blah, whatever, they will be packed into one primitive. And this means that by enabling this name attribute name, we will now have 100 points, 100 primitives, 100 vertices, and 100 packed fragments. The same goes for this exploded view that we used earlier. This does use the name attribute to explode these pieces. Because if we didn't do that, we just deleted the name here, it wouldn't do anything. Yeah, so it actually does use the name, which means that if you see this piece here, if you go ahead and delete that and delete non-selected, we can see that this piece all has piece 70. Alright. It might be a little bit tricky to understand at first, but these are going to become very useful, and it's super awesome that this Voronoi fracture node does this for us. It helps our lives. It makes our life so much simpler, regardless. So we now have a 100 packed fragments. Great. We are going to use the V and W attribute here. We can switch it off later if it looks weird, and then add a null after that, and that's it. That's it for the sub level. We now have this fracture box, moved it up, and has some attributes on it. Let's dive into the DOP and see what's going on in there. So inside of the DOP, we're going to use the RBD packed object again, which is very handy since we have 100 packed objects. We're going to locate the subpath. We're going to inherit the velocity and point velocity. And we're going to connect it to a bullet solver. We're going to do it to the ground plane, just the regular stuff and the gravity. And let's see what this looks like. Boom. It basically flies up and apart because of our inherited velocities. Let's go ahead and disable this and dive into again. I disabled the point velocities, the velocity and the angular velocity. Let's see what that looks like. So now I'm gonna just drop down and crash and explode. Yeah, so that's really cool. That's how basic, very, very basic fracturing works with the bullet solver, and how to do it with packed objects and how to pack it and then bring it in. So yeah, I guess I should show you. If we go to this node, we can just simply see that instead of bringing in one object, we now have 100 points and 100 prims. So yeah, that's cool. Yeah, so this is how it looks like when you're in sub level. Just gonna quickly run it again. Boom. And it's very fast, very like accurate, and yeah, it's pretty great. So that's all for this example. I'll see you guys in the next tutorial. Thank you.